In this demonstration, we're going to look at the negative acceleration of a cart along an incline plane or a ramp. And so we see this metal track in the foreground of the video. At the very bottom of the track, there's a motion detector. That motion detector will collect information about the movement of a cart along the incline plane or ramp. So I'll give it a little push and it will travel up the incline plane, slowing down as it rises and speeding up as it rolls back down. In the background, what we have are two graphs. At the top, a position versus time graph for this motion, and at the bottom, a velocity versus time graph. We'll be able to look at these two graphs as the cart's actually moving and see what we can find out about how the motion is associated with the graphs. So here we go. Okay, there we have the graphs. At the top is the position versus time graph, and we'll look at that one first. We notice that once the cart is given its initial push, it begins to move in the positive direction. That is, the slope is positive. On a position time graph, the slope is the velocity. That all happens until about the 2-second mark, and at the 2-second mark, the slope is now 0, and the object's at its highest position along the ramp. After which time the object begins to roll back down the ramp, the slope becomes negative. So the object's now moving in the negative direction. We have negative slope, and the slope's getting bigger and bigger over the course of time until finally it gets near the bottom and I catch the cart. Now on the velocity time graph, we see something distinctly different. We see a negative sloping line. Once the cart's given its original push and is up to speed, it begins to roll along that incline plane, rolling up the incline plane but slowing down, and that's why we see this line on the velocity time graph approaching a velocity value of 0 meters per second. We notice that there's a negative slope on this graph, and a negative slope on a velocity time graph indicates a negative acceleration. The cart's got a positive velocity. It's moving rightward in the positive direction, but it's slowing down, and that's a negative acceleration. All of that happens until this point, right there. That's the 2-second mark, and at the 2-second mark, the cart's at its highest position. And after that time, the cart's going to begin to roll back down the ramp. What we see on the velocity time graph is that line goes underneath the v=0 point. The velocities become negative. The lines cross the axes, and the velocities are now negative. And they're getting to be bigger and bigger and more negative velocities, indicating the negative, the cart's moving in the negative direction, and the bigger velocities indicate the cart's speeding up, until finally it reaches this point. It was the time when I caught it and pulled it off the track. So there we see the connection between a position time graph and a velocity time graph for an object with a negative acceleration. Two ways to get that negative acceleration: move in the positive direction and slow down, and then after the 2-second mark, move in the negative direction and speed up. Thanks for listening.